All right, today we're going to be talking about Ruby on Rails. So I have a couple of programs here. This is a course outline for learning Ruby on Rails, and in today's class, we'll be talking about the control flow. So I'm going to be having you will have the command, the installation, create Ruby application, data type, variables, and constants. We've covered all of that. So today I'll be doing some exercises on control flow, how to understand the basic control flow and the program structure for every not just in Ruby, every programming language whatsoever. All right, so that's what we're covering today. Now I'm going to create a folder here, a file here, sorry. So the file, I'm going to call it control. You can call it anything you want to call it, .rb, that stands for Ruby. So once it opens, I'm going to do Control B to hide my windows. All right, so that I can have more room here to type. So let's make sure this is working. So let's say puts hello world. Okay, so we can run the program here by simply saying Ruby control dot rb. Yeah, so we'll get hello world, which means the program is running successfully. Right, so that is what we'll have. All right, that's how we'll be running this program for now. Right, so let's look at some control flow. So we're going to be doing some exercises together. The very first exercise we want to do is to dictate odd and even numbers in Ruby. So we're going to write this as a full-fledged program using a function. We've done function before, so you should be able to know this, right? So I'm going to say def just like we do in Python. Def. I'm going to call it let's call it odd underscore or underscore even. So this is going to dictate whether a number is odd or even odd or even number, right? So here I'm going to say print. So you can also use print here. You can even use it with parentheses if you want to, but I'm just going to use it like that. I will just say enter a number that's from the user. So the user should enter a number. So I'm going to get the number that the user is going to type. I'll call it num. Of course, you can call it anything you want to call it. I'll say get. So the way we get content from user is by using the concept of get. So get is a method. So I'm going to say get.jump, and then what I want to get is I'm going to say to id, that's to integer, to I. So it's going to get the integer of that particular the return, whatever the user type will be returned as an integer. That's what I mean there. All right, so I can come over here and say if there's a control flow, if num dot even. So it's very simple in Ruby. You can say if it is an even number, just like we use this is then. This is like saying then. That is a ternary operator. This is a ternary operator. I can say puts. So the way we print something out, we can say print or put. I can just use my template string here. I can say num. So this is how we use template string. You put just like in Python 2 and JavaScript. We use parentheses here to get this done, right? So just put hash in front of this for hexadecimal value, right? So that is how it works. All right, so what we need to do say is, so if it is even, we're going to say that number is an even if I can spell even number, yeah. So very simple. Then we can look at the else statement. So you can say else, the same thing. You can say else. Yeah. So else, we'll just say puts, the same thing. We can say num, which is the number, is an odd number. Yeah. So we can do that. At the end, we want to end our if. So we can end our if here, and then we can end our program. Yeah. So this is a simple program that will give us an odd or even number. So we're going to try that program now. So close the program. So remember, this is a function, so I need to call the function. So I'm going to call it by saying odd or even. Just call it that way, and then run the program, right? So instead of typing Ruby, Ruby control, can I spell control dot rb? Every time I can just press my arrow key up. So we're going to look at that. I can just press my arrow key up. Alright, so let me enter a number. Let me say enter 16, press enter. It's going to tell me that 16 is an even number. So I can run the program again by pressing arrow key up. And when I do that, okay, now press enter. It's going to ask me to enter another number. I'll enter 19, press enter. It means 19 is an odd number. So that is how it works very easily. So we're going to be creating other programs right away. So that is very simple. So you can practice more with this, get to get other numbers and make sure you use it and work out something. All right, so let's do the second program. All right, so the next program we're going to be looking at is let's write another program. So this program is going to be, so this is dictate whether, let me write a comment there. So we'll just say control slash, going to say dictate whether a number is odd or even number. All right, so that's what we'll have there. Now I'm going to be writing another program. This one will be to so this one I want to dictate whether a number is positive, negative, or 0. This is quite simple. I mean, you can pause the video and just try it out on your own and see if you can get it. If you can't get it, then you can continue the video and see how I do decoration. So I'm going to write it as a function again because I'm working on control flow, right? So I'm going to just call it positive. Let's use smaller p. So positive underscore negative underscore 0. So that's what the name of my program is. So again, I'm going to say print. I'm going to prompt the user with this. Tell the user to enter a number. A number. All right. So when the user enters a number, what I want to do is I'm going to create a new variable again. I will use num. I'll just say get chumps or chump dot to integer. So to integer, I'll have to float. I'll have to string and other things, but I'm using integer anyway. So I'm going to come over here and say if num, which is that number they typed, if it is greater than 0, okay, very simple. If it's greater than 0, I'm going to put that number again. Just say num is positive. Otherwise, else. Okay. Before instead of else, I'm going to use else if. So I'm going to say else if. So in Python is else if. Why here is else if. Understand? So they are very similar, just a little different, right? So I'm going to say if num is less than 0. That would mean that that particular number is a negative number, right? That's what it means. So finally, we can have our else, a concluding statement. I can say puts number is 0. So this number, I'll just say num is 0. Okay, so that's what we can do. And again, finally, we can just end the program, end the if statement, control statement. The next thing, to run this program again, you can say positive number that. So once you save, come over here and run our program. Let's clear this first of all. Run our program. It will say enter a number, so I can enter 133 in any number of my choice. Press enter. It will tell me that this number is positive. I made a little mistake. It's not really a mistake, but I just want to put space here. Yeah, save. Then run the program again. So enter a number, enter negative something. It will say this is a negative number. Of course, if I run the program again and enter 0, it will tell me that 0 is 0. That's fine. So very simple control statements that we can use in our program just for practicing to be able to do that. So let's look at another one. Let's say we are given 3 numbers and we want to know among these 3 numbers which one is the highest in value. Okay, so we're going to say get among 3 numbers. Oh, no, I'll just say get the highest value among 3 given numbers. So pause the video again, see if you can achieve this. If you can, go ahead by all means and try it. But if you can't, just continue the video and see the results of how we're going to do it. Very simple, straight to the point. Again, what I want to do is to define a program that will say highest number. Let's call it highest number, or let's call it let's call it highest number, or call it highest of 3, highest, no, let's call it greatest of 3, just let's call it greatest of 3, greatest underscore of 3 underscore 3. So among 3 numbers, we want to get the greatest number there, or the highest number, anyhow you want to put it. So we're going to say print, let's say enter a number again, enter a or let's say enter first number, let's be specific, enter first number, and then here that first number, I'll call it I'm going to call it a, but you can let's call it num1, right? Num1 is equals to, is going to get that number, so say chomp, and then want to get, want to say to I, and then that is for the first one. And then I'm going to copy, okay, let me not copy anything, I'll just say enter second number. Okay, so second number, I forgot to put this, very important. It's not that important anyway, you just have to, something you have to do. So so here I'm going to call this num2, say gets dot chomps, or chomp dot to underscore integer. That is for second number. And then for the third number, I'm just going to copy and paste because of time, I don't want it to be too long. So I'm going to come over here and just copy and paste. This will be the third number, and then I'm going to do that, call this the third number. Alright, so we have num1, num2, num3 that we've gotten. So all I have to do now is to write my control flow, which is going to be say if I'm going to start with my num1. Okay, so if my num1 is greater than or equal to num2, okay, then end. If you recall, end simply is a logical statement, right? It's comparing, we'll be comparing between two logic statements here. So what I can do is to simply say end. So I'm going to compare the second number, num1, and I'm going to say if it is greater than or equal to num3. So we have 3 numbers in the control flow. So the num1 is the first number. We're checking if the first number is greater than or equal to the second number, right? And then we are comparing using logical statement to check if the second number, if the first number now is greater than the third number. So the first number if it's greater than the second number, and then the first number again if it's greater than the third number. I think that makes sense, right? So we're going to say puts. So we'll output our program, we can say puts using our object literals. So we can say num1, which is the first number, is the greatest number. Okay, so if the first number is greater than the second number and the third number, remember and is not all, okay, it's and, it has to be 2 of them. So that we did that in control flow, so be mindful of that. So if the first one is greater, we'll say the number is the highest number. Okay, that's the highest number in value. Okay, something like that. Now we'll go to the else statement. So we're going to use else if, okay, which should be here, it shouldn't be there. Yeah, so else if num2, so we're looking at num2 now. So the same thing, if num2 is greater than or equal to num1, right? Num1, and the same num2 is greater than or equal to num3, right? So if that be the case, it would mean that, let's put again, puts using template string, num2 is the highest number in value. Okay, so if those two cases were not true, it would mean that num3 is the highest number in value. That's what it would mean. To mean that num3 is the highest number in value. So to do that, we just say puts num3 is the highest Okay, so all we need to do now is to end our program. So we can say end for the control flow if statement, then end our function. So we can come over here and call the program, say greatest number of 3. So if I run this program, let's do that quickly. Make sure save. Okay, run the program. So it's going to say enter the first number. I'm going to enter 67. Enter the second number, enter 23. Enter the third number, enter minus 19, that kind of a thing. So you say 67 is the greatest number. Of course it is the greatest number, so have that program there, and you can go as far as checking other numbers, right? And what if we have 40 numbers? What if we have 100 numbers? What if we have about 1000 numbers? How are you going to do that? So that is another thing you can think of. What if we have 1000 numbers and we're supposed to check the highest number among those 1000 numbers? What are you going to do about it? And what if in a scenario whereby two numbers are even equal, right? What if there are two numbers that are equal? What is going to be the problem? So these are the bugs we can fix in this particular program, okay, making it more robust, and also to be able to cover more scope, right? That's what we mean. All right, let's move to the next one. So you can attach that to the maybe I can write it as a comment, right? Write program for 100 numbers, or let's say 1000 numbers, and also if two numbers are equal, two or more numbers, right? If two or more numbers are equal. All right, so we can consider that in improving the program. All right, so let's move to the third program exercise that we need to do. That one says we need to get the leap year, right? So get a leap year. So I'll pass in the leap year. I'll pass in the year. It will tell me whether the year is a leap year or if it's not a leap year, that kind of a thing, right? So let's do that. So we're going to define the function again, and we're going to call it leap underscore year underscore check. Okay, leap underscore year underscore check. That's what we're going to do. So we're going to say print enter any year, enter a year, enter a year. And then what I want to do is to get the year. So I can say year is equals to get dot jump dot to integer, right? So that's what I want to do. Then simply using my control flow again, I can say if. Now I'll open parentheses here because I want to write some bunch of conditions, and I want them to run in a synchronous way. So that is why I have to do that. So I want the ones inside this parentheses to be compiled as a single program flow. Then others can follow suit, right? So that's what I want to do, right? So what I can do here is simply say if year. So I can check the year using modulus when it is divided by 100. So when you divide the year by 100, if it's not equal to 0, so you remember modulus as an operator. I think it's an arithmetic operator. I think it's an arithmetic operator. So if when divided by 400, not 100, 400, when we divide this year by 400, okay, when the year is divided by 400, it should be equal to, sorry, I'm making a mistake, let me start with this one first. So it should be equal to 0. So year percentage divided by 400, I'll do that of 100 first, I mean later. So year divided by 400, if it's equal to 0, okay, or so another condition is check if that year, when the year is divided by 4, is it equal to 0? That's the remainder. You understand? When this year is divided by 400, the remainder is it 0 or 1? So it cannot even always be 0 or 1. And when it's divided by 4, is it 0 or 1? Or again, or when it's divided by 4, okay, when you divide that year by 4, if it's equal to 0, if there's no remainder, it will mean also it's a leap year, right? So and then want to check another condition, can say and. So and or is not the same thing. Then and this is second condition. So if this is false, it's fine. If this is true, it's fine. If this is false and this is true, it's fine. But where the problem comes is the and, because for this particular logic statement to run, this side of the equation should be true, and the next side I'm about to write should also be true before this equation will run. I think that makes sense, right? So that is what we can do on that, right? So we can do all of that if it is true. Or let me write it this way. So let me write it this way. So I'll put the and here, write it together. So and yay, and the year is that's it, divided by 100. Let me do that one here. I wanted to do it separate, but let me do it here. Is not equal to 0. So if it's not equal to 0, so look at what I did. So this side, this whole side should be true, and this side should also be true. Sorry, there is or. Okay, so this side should either be true, or this side should either be true. If anyone is true, then the program, which is put, this program will run put. Let's use a template string. Yeah, is a leap year. So this program will run. It will be a leap year, right? However, here we have two conditions. For this condition to work, for this one to return true, it simply means that this side has to be true and this side has to be true. Okay, so two of them is true. So when divided by 100, it is not equal to 0, but when divided by 4, it is equal to 0. You can also use 2 here. You can also use 2. Okay, but it's all fine, right? So that is what we have here. So else, of course, if that is not the case, it means it's not a leap year. So we can just say year, which is the year they typed, is not, in capital letter, a leap year. Okay, so that is that on the program. So let's close this program. These are the program that will help you to master Ruby on Rails, or Ruby to be more precise. So let's run this program and see. So I've saved the program, Control L to clear the screen, and then arrow key up to bring out the last statement we just ran, and just click enter, and to ask me to enter a year, right? So let me enter 2021, right? It says 2021 is not a leap year. Of course it's not a leap year. Let me put something here very quickly. So put space here so that it doesn't attach itself here like this. Okay, so that's why I did that, right? So let's clear this screen. So run the program one more time. Let's enter the year 2000. So 2000 is a leap year, right? So 2000 is a leap year. So that's how we know leap year and the one that is not a leap year, right? So very simple, very simple. So that's the program. You can even enhance it more by fetching a card. Okay, we'll do something like that. I think we're going to do something like that. You know, you can go as far as getting the number of days in a leap year and all those things, you know, maybe getting a particular day and stuff like that. Okay, in a week. All right, so let's move on. Or you can even fetch, let me put it here. Okay, let's say fetch, sorry, so fetch all leap years between let's say between 1990 to 2005. Yeah, okay. So fetch all the leap years between 1990 to, so it's going to output all the leap years between 90. This is like an exercise. You can give it a shot. I mean, it's a little bit simple. It's not that difficult, but we're going to introduce a loop here. Okay, we're going to introduce a loop. So it's just like running this program again. You know, we'll be running this program again, but then we'll be introducing a loop. So at this point, before we do this, we introduce a loop. So the loop will run this program for every year in that particular sense. So it's going to be it's very simple, very simple. But just give it a shot and tell me what you think. Just chat me up and tell me what you think, maybe in the comment section or something, right? So let's move on. So the next program we're going to be doing is a student resource system. I like doing this program. If you check my other videos, you see where I did students. I've done it in Python, in JavaScript, in PHP, in some other languages. Okay, so we have students resource management system, students resource management system. Okay, so we have this program. So I'm going to call it a grade system. So let's define, first of all, define grade underscore system, right? Sorry, underscore system. It must be written together. Can I write system? Yeah. All right, so that is what we have. So we're going to tell them to enter the marks of the student between 1 to 100. Okay, so before then, let me make a note here. So the note is going to be that anybody that scores between 70 to 100 will score A, right? Anybody that scored between 60 to 69 would score B, and anybody that scored between 50 to 59 again will score C. Yeah, C. Anybody that scored between 45 to 49 would score D, if I'm right. Yeah. So anybody that scored between 40 to 44 will score E, and anybody that scored between 0 to 39 will score F, right? So that is the result grading point, and anybody that doesn't have any of these scores, so anybody that scores anything outside of 0 to 100 has RA, right? Would call it as RA. That's result awaiting, or no results, no results, or awaiting results, or stuff like that, So, or actually nil, can use nil, that means no result at all. All right, so that's what we want to go through in this particular order, right? So let's move on with this. So the very first thing we want to do is to print. Want to print enter students. So you can use, like I said, you can use parentheses for print if you want to. You know what, let me just use that here. So you can say enter the student score, or enter a student's score. Okay, so that is what we can do. Enter a student's score, so they can enter a student's score. So we're going to call it let's call it score here. Set it equal to get. So we're going to get the student score here. Jump dot want to make sure it's integer, so say to integer, right? So that's what we want to do. So we're going to now test this variable using this our marking scheme. This is our marking scheme, or score sheet. Okay, score, yeah, remarks. I don't know what you can call this, but then something like that. So let's use it and test that. So we're going to do a very simple if statement. Now we're going to say if. Now we're going to put that condition into test. I want to say if so if score, let's start with this. If score is greater than or equal to 70. So if it's greater than or equal to 70, okay, and we want to make sure that that score is less than or equal to 100. Now the reason why I need to do this and is, I mean, you can use or, right? If you use or, it will now be checking whether the score is less than 100. So anybody that is less than 100, whether it's 20, whether it's 10 that is less than 100, it will still be A, right? So but then if you put and, it simply means you are making sure that these two conditions is satisfied. First of all, the person has to score 70 or above, and so this should be true. This side of the statement should I put it in parentheses so it will make sense? Yeah, this side of the statement should be true, and this side of students, I can also wrap this one in parentheses too. I mean, it's not necessary, but I'm just trying to say, you can just leave it like this, right? So this side of the statement should be true, and this side of the statement should also be true for the person to score. So let's say put your grade, or just say grade is A. Yeah, so you need to score 70 or above, then make sure you're scoring 100 or below. Now you can't score above 100, right? So if you do that, that will be an arrow in. That means you did a zero. All right, so let's look at if. I don't know why it's there, so put it back. Whoa. Okay, so in Ruby, if you've noticed, indentation is very important, just like in Python, and I think in Objective C or something like that. So always do that. So I'm going to copy. Okay, let me not copy that. So I'm going to just say score. So we're looking for the second mark now. So for B, for it to score B is 60 to 69. So let's do that. So we're going to say if you score anything less than 70, so even if you score 69.999999, once it's not 70, you are scoring B. And then sorry, less than 70, sorry, okay, let me do it this way, let me say if you score anything above, okay, let's start above or equal to 60 first of all. Remember, this is 60 and above. Sorry, I made a mistake. So this should be 60 and above. So 60, so score should be greater than or equal to 60. And let's make sure that that score that you have is less than 70. Yeah, less than 70. So you should score above, you should score 60 and above, but your score must be less than 70. So to do that, we'll just say put grade is B, right? So let's move on very quickly. So we're going to come over here and do the same thing. Else if score until we get all of them. So the next one is 50. If it's greater than or equal to 50, then we want to make sure that is less than, score is less than 60. If you guess that right? So you must have a score 50 or above, but it must be less than 60. So less than 60 is 59 point something 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 something. Let's make sure we are having C here. Okay, so we can say grade is C, right? That's your remarks is C. So we can do another else. So we can say score is greater than or, so we're at 50, so we're looking at 45 now, or equal to 45, and want to make sure that your score is less than 50. Yeah, so we want to put that you're scoring D, right? So the grade should be, grade is D. Okay, let's move on a little bit faster now. So we have else, so we have to score is greater than or equal to 40. So if you're scoring 40 and above, score, so what we can do here is say less than 45, if I'm not mistaken, less than 45. Yeah, less than 45. Let's put space there, less than 45. So here that should be an E, grade. Can I write grade? An E. And then we'll have another one here. Whoa, we'll have another one here. So from, so we're looking at F now, right? So we can say if you score anything greater than or equal to 0, and then you have a score that is less than anything less than 40, right? Yeah, anything less than 40 is so that should be an F. So the grade should be F, right? So finally, else, so if you don't have any of these scores, it simply would mean that your grade is awaiting results. That means your result has already processed, or there's an error somewhere. So just put RA, result awaiting, on NR, or there's no result for you because for some reason your score has to fall in between all of these. Otherwise, you don't have any score. All right, so that's what we have there. So let's quickly end this program and then end the function, right? So let's check the program and see how it works. So we have grade system. Let's say a student scored let's come over here, please. Okay, so here, can I move this up, or let's just run the program from here? So let's run the program now. So say enter a student's score. Let's say this school scored 67 or something like that. Great. So this guy scored B. That's nice. Let's say a student scored 101. Enter. So the student has arrow A because you can't have over 100. Let's say the student scores anything lower than 0, so minus 15, 25. So the students also have arrow A because you can't score. That's not a valid score. I don't know if that makes sense. So that is what we have in this result computation system. You can use it to implement it in your program. Maybe let's say you're doing a school resource system or something. That's where you can implement something like that. All right, so on your own, try to see if you can take it a bit further. For example, you can okay, maybe when you do the GUI, we can implement something. We implement some formatting, right? So that maybe F can be red and all that. We can use colorize using gem. I think we'll do that in the next class. We use gem, import look at here, gem file. Gem file is just like package or JSON file. We can import, colorize, and any other dependency that we can use here, right? So anyway, let's leave that. Let's finish with the control flow, right? So that is what we can do from there. The next thing we want to do is, okay, another thing you can do here is to actually compute the scores yourself. Okay, so let me just put something here. I can say compute the scores and the average. So you can compute the score. Like for example, you can be given the raw score sheet, right? Let's say English, the person scores 25, maths in the CA, then in the exam the person scores 60. So you're going to compute it, do like the computation yourself. I mean, that's very possible too, right? I think I've done something like that in one of my videos too, in one other language. I think it's vb.net. We did this in the channel. All right, so you can check that out. All right, so let's move on. The next program I want to do is factorials. You can recall in mathematics you have permutation, combination, probabilities, all those kind of further mathematics concepts. So you can there are things you can try with programming, right? So one of the ones we want to try today is called factorial of a number. So if you can recall, okay, let me just write that out first. So a factorial of a number, or of a given number. So factorial, how factorial works is simple. It enables you to get the factorial of a number. For example, if you say factorial of 5 is going to be 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is going to give you, I think, 120 or so. So this is the factorial of a number, right? So anytime you are given asked to find the factorial of a number, this is the formula that we are going to be using. So this time around, instead of writing it 1 2 3 4, we don't know a number, so we're going to be using a loop to do this, right? So it's part of the control flow. So I'm going to say define factorial, if I can spell it very well. Factorial. Okay. All right. So I'm going to say print. You can put it in parentheses or not, anyhow that is convenient for you. You can say enter a number, and then you can just get that number. I'll just call it num as usual, and I'm going to say get dot chum dot to integer. I want it to be an integer. We'll be using integer most of the time. So for the factorial, I'll just call it fat1. So fat is equals to, initially fat is going to be equal to 1, and then we'll just add it up from there. Append the multiples of that number. Like if you multiply 5 by this, just append the result to fat, and then continue like that until the number is exhausted, right? So that's what I want to do. So I'm going to use for each. So normally use each. So if you want to loop numbers between 1 to a particular number, so you're going to be using each for that number. So I'm going to say from 1, count from 1. You can even say count from fat if you want to, but I'm going to say count from 1 to the norm. That's the number that is given to us. Count from 1 to the number. So it's going to be just like range in Python. It's going to count between 1 to whatever number the person will type here. Okay, let me put it in parentheses. Here so it will make sense here. Count from 1 to the number the person is going to type, then each of the number. So for each of those numbers the person is going to type, now we're going to find the factorial. It's very simple. I'll use curly braces here for my method, and I'm going to define a new variable. The variable, I'll call it I. I stands for iteration count. That's what I want to call it. You can call it J, you can call it K, you can call it anything you want to call it. It is your choice. So I'm going to say let I, okay, I is my new variable, which is each of the numbers that is here will be represented as I, right? So I'm going to take this fat variable that I have here, initial variable I declared as a local variable, and I'm going to take it here, and I'm going to say let at every point this loop is going to run, let it be multiplied by the number that is there. So if it is 5, that assuming the person types 5, it is going to multiply. The first loop is going to be 5 times 5, it will be there. The second loop is a 5 by 5 multiplied by 4, it will be there. The next one by 3 multiplied by sorry, the first one will be 5 times 4. The second one would be, as the second loop, will now be 4 multiply by 3. As the loop is running for each of the number, it will be multiplying them, and when it multiplies, it's going to append, that is the essence of the quality sign, it's going to append the answer to this particular fact that I have here. So instead of being 1, it will not be something else, maybe 20, the second one it will be 15, and so on and so forth until it gets to the last number. So at the end of the day, all I need to do is to print my sum. So I can say so I can just say let me say or I don't know. Or let me just put it out. I just call it factorial, sha. Let's call it factorial. There's something else came into my mind. Let's just call it factorial of, let's put that number there. Let's keep it simple, right? I wanted to add something now. Okay. We'll just put the factorial out. So factorial is going to be given to us by the fat number here, because that's where we append. Whoa, that's where we are appending. Oh, can I type? Yeah, that's where we're appending the number. So because we're appending the number here, I'm going to say the factorial of this number is this. Okay, so that's it. So let's just end the program, and then here I can just call factorial parenthesis. That's all. So I'm going to push this program up, this a little bit up. So I'm going to run our program again to say enter a number. Let's enter 5. Enter. So factorial of 5 is 120, like I already told us before. So you can let me I keep forgetting to add this. So factorial of the number is 25. So you can do factorial of any number. For example, let's try factorial of let's say factorial of 10. Okay, we'll get that. Okay, and so on and so forth. All right. Okay. All right. So what if we're asked to get the sum of numbers? Let's say you're given an n number of value, and you're supposed to get the sum of the numbers between that. Factorial is multiple, right? So we can get the sum. Actually, instead of multiplying, we can get the sum. So instead of having multiplication sign here, we can have addition sign there instead, right? I don't know if that makes it. No, let's just give it a shot. So here we can write another program. So I'll just put a comment here. Get the sum of numbers, right? So we can do that. So to that, we can define a variable. Let's call it sum, not same, sum underscore of n numbers. So we don't know the value of n, so we're going to find out from there. So we're going to print again. You can use parentheses or not, anyone. Print, I'll say enter enter n number. Okay, we can do that. Enter n number. So here what we're going to do is to say n. This time around, let me call it n. We're going to just get that n number. So get dot chomp dot to underscore I, and that's what I want to do. And I can call it sum. So let the sum of number be initially equal to 0. So the sum is initially equal to 0. I'm going to use my for each again. I like putting it in parentheses. I'll just say from 1 count up to the number they typed dot each of the number. You remember we have other loops. Okay, we have for loop, we have while loop, we have times loop, we have I'm thinking of the first one, while loop. Okay, no, I've mentioned while loop. We also have one other loop, until. Okay, we have until. So those 4 types of loop, we have them in I mean 5 types of loop, we have them in Ruby on Rails, right? So excuse me, you can have that. So I'm going to write my program here. I don't want to write it under. So I mean, you can write it under if you want to, but I want to write it here. So I'm going to say my variable iteration count is going to be I. I mean, it can be anything you want. It's going to be I. So I'm going to say sum plus equal to, just like we did before, of I. Okay, very simple. Very simple. All right. So that is what we have here. Right. The next thing I want to do is to just put out our results. So we can just say sum of first number. So let's just put it n, which is the number we typed, the number they typed. So we're going to say numbers, n numbers is, we can just put out the sum, right? Just very simple. The sum is this particular sum here. This particular sum we have here. Oh, sorry. Yeah, this sum. This one. That's what we're talking about. And this is our n number here. This is our n that we're using. Okay, so the sum of the first number, this number that we have here, is, now we'll put out the sum itself, which is this number where we have saved all of that. So that's what we're saying. So here you can come over here and simply say sum. Yeah. So once we do that, we are done with this program. So we can just say end. Again, let's push this across. Hopefully we don't have any errors. I don't know. Hopefully we don't have any errors. So I'm going to sum of numbers, just call the program, and then can come over here and run the program. Let me Control L to clear, run the program. It's going to say enter numbers. So let me enter something like 7. It's going to sum it up. So 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is going to give us this. You can try that out, but I'm not going to be trying that out right here. So that is it. So I mean, we've done multiple, we've done addition. You can also do subtraction and try other ones, even division and other ones. You know what, let's do multiplication table. Whenever I give you a number, you're going to give me the multiplication times of that table, like 2 times 1, 2, 2 times 2, 4, 2 times 3, so, stuff like that, until maybe 10 or 12th or 15th value of that particular number, right? Using loop again. So we can actually do that, which is very simple. So I can say get multiples, get multiplication table, multiplication table of a given number. Let's call it n again. Okay, I mean, you can use anything. So I'm going to say define, let's call it multiplication, multiplication table. Yeah, let's call it multiplication table. I think that should be a descriptive name for it. Again, we can print, you can use parentheses or without parentheses is fine. Enter a number, make sure put space there, and then I want to get that number. I'll just call it num. You can call it anything, and get dot chomp dot to integer. Okay, so we can do that to get the number. So first of all, what I want to do is to output the multiplication. I'm going to say multiplication table for this is, then I'll write the number. I think it makes sense like that. So I'm going to say put here I'll do multiplication, I think I'm right, multiplication table for, or let's say of, not for, of this, that's our given number, we'll put space there, and then we can just say count from 1. So count from 1 all the way to, let's say, to 10 or to 12. Okay, since multiplication table is always to 12 dot each, so count from that to, for each. Then here what I want to do is to just put my iteration count again, using my iteration count I mean, you can use j. Okay, let's use j. You can use anything, any of the value. You can even use k or anything, but the convention is always to use I because of iteration, right? So but it's all fine, anyone you want to use. So here I'm going to output my result, and I'm going to say that let the number they typed, okay, is going to multiply. That number is going to actually multiply. That number is going to multiply. I'm going to use this multiplication strategy to make sense, like times times the number of I, the each of the loop. So it's going to be j, each of these numbers. Okay, so from 1 to 12, it's going to count each of those numbers, and it's going to actually multiply them, and it's going to give me the answer. So it's going to be equal to, so it's going to give me something like 2 times 2 times 1 equals to, it's going to give me the answer, and the answer is going to be the multiple of those numbers. So the multiple is simple. I'm just going to open this parenthesis and just say number times j, yeah, which is going to be the actual multiplication. This is going to multiply this and give me the answer. So this times this is going to multiply and give me the answer. Very simple program, very simple program. So let's run it and say multiplication table, run the program, save. So I'm going to print a new line. Well, let me show you how it's going to look like first. Though by default put will print a new line by default. So had it been I'm using print now, it will be printing all of them in the same line, but because I'm using put, it will be printing them in separate line. Then this will be in the first line, the second line will be this, the third line, and so on. So let's see how it's going to run. So enter that. Let's say I want a multiplication table for 2 times. So if I put 2 here, press enter, it's going to tell me that 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 2 times 6 is 12, 2 times 7 is 14, till 2 times 12 is 24. Okay, let's try another one. So I'm going to try a multiplication table for 9, right? So let's run the program again. So let's enter 9 as they want to get the multiplication table for 9. Press enter. So it's going to give us all of them. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, and so on and so forth till up to this, right? So it can be handy sometimes if you want to teach children, or you want to, just print the program multiple times for anything. So what I want you to do is to try the division table. So division, this would have been division, you understand, this should be not division. If for addition, this should be addition. So subtraction, this should be subtraction, and so on, right? And so on. So just try that out and then let me know what you'll be able to get. All right. And mind you, if you are doing division, there are some things you need to watch out for because of zero value and all that, and decimal points. So just watch out for that. Okay. The next program I want to talk about is the reverse digital string. To reverse digits, let's say someone types 1 2 3 4 5, you reverse it to 5 4 3 2 1. The concept. So how do you reverse a string in programming? And this works for every other program, but I mean in Ruby it's very simple. You can just put the reverse function. There's a reverse function that helps you to reverse the string. But in some other program, what I want you to do is to try doing it manually without using the inbuilt program, or inbuilt method for this, right? So maybe in one of those videos I will cover that up, how to do it, but now I'm going to do it in a very simple way. So I'm going to say, okay, let's put the title. Let's call it reverse string or reverse digits. Yeah, let's use digits, reverse digits. All right, so we're going to say define reverse underscore digits or digits. Okay, so what I want to say is print, open my parentheses and say enter a number. So I'll just call it num, of course. Pardon me. Chomp dot to string to I, sorry, not to integer, and then the reverse string I'll just call it reverse is equals to, which is very simple. Just take that number, make sure that number we're converting to string. So I'm going to say to string to x, so to underscore x, to convert that number that just typed to string, because this reverse function works only for strings, so it doesn't work for numbers most times. So we need to convert that particular input that we got as an integer to string, and then we can just simply say dot reverse. And when we do that, that's all we need to do. We can just print out our program. We can use print or put, anyone, like I said before. We can say reversed reverse of that our particular number that they typed, or the series of numbers they type, is now the reverse, which is rev. Okay, so that is how simple it is, and then we can just end the program. Then make sure we call the reverse string digits, and then if we run the program, let's come over here and try that out. So run the program once, hopefully no error. So if I do 1 2 3 4 5, enter, I'm going to get 5 4 3 2 1. Very simple, very simple. So let's try something else. This one, let me try alphabet and see what will happen. Let's see. I try cybergate. So the reverse is 0. Why? Because recall that what we are getting is what we're getting, what integers. But let's say, assuming we're getting string here. Let's say we're getting string here, even though it's digits, which is number, but let's just assume we're getting string here. So if I do that and press enter, then try that program again, you see this time around it's working. It's working because now we're getting string and not integer. These are the things you need to try out just on yourself or by yourself and see if you can get that right. So but I'm working on string, so let me leave that. So working on integers. So but if you're working on string, you see what I just did, just change this inverter to string, and then you can work on string and then possibly other numbers. And I think string also works for numbers, right? Let's see that string also works for numbers. S, save, make sure it's still in S. So print this out again. For numbers again, I'm using string. Oh, remember, I'm using string. So you see, it also works for numbers. String works for both numbers and string. But when you want to be strict, you want it to be just integers, you can just use I think that makes sense, right? So that is it on that. The last program I want us to write today is called the factorial of a number. Sorry, factorial. We've done factorial. Let's do Fibonacci. Sorry, Fibonacci. So Fibonacci is a concept declared by a man. I think his name was actually Fibonacci King Kong Ho or something. One China name, funny name like that. Sorry. No disrespect, no disrespect. So, he's a man. You can read about Fibonacci. He's a great man, great philosophy. He's an analyst, and he proposed the theory of Fibonacci of a number, which gives you series of numbers in a particular nth term of those numbers, right? It's just like we have a geometric progression, we have arithmetic progression, or progression. Is it progression? Yeah, in mathematics, where you can say, like for example, arithmetic progression is something like 2 4 2 4 6 8 10. So where and a progression is happening in addition, like this plus this plus this plus this. So 2 plus 2 is 4, 4 plus 2 is 8, 8 plus 2, 4 plus 2 is 6, 6 plus 2 is 8, 8 plus 2 is 10, and stuff like that, right? That's arithmetic progression. Where we'll have geometric progression, where numbers um, increase by multiples of 2 or multiples of 3, multiples of 4, depending on what the multiples is, right? So we can have something like 2, 4, 8, 16, 32, 64, stuff like that. So that's geometric progression. But let's look at Fibonacci theory, and it's a nice practice. It gets you, to understand how Fibonacci actually work and how numbers can be manipulated into something, right? So we're going to define. Let's first of all write the name of a function, which is going to be Fibonacci. Fibonacci. It's a concept we use it even in trading, in analysis, stock analysis, and crypto analysis and stuff like that. Okay, so let's define the method. So we're going to say Fibonacci. Fibonacci. I think that's how it's pronounced. I don't know. Okay, I don't know. So this is our method. So again, we're going to just prompt the user. Whoa, let's prompt the user. So print from the user. You'll be wondering, why do I use print for this? Because it writes in the same line, and then I use puts because it outputs in different lines. Very simple. But if you don't want, you can still use new line here. Use this one. If you use this one, use this new line, something like this. It's going to print in different line also. So, but that's it. All right. So I have a enter. Let me use small letter. I don't know why I'm using cap locks. Okay. Enter the number of terms. Can I type? Alright, so that is what we'll have there. Enter the number of terms, okay, for your Fibonacci, right? So that's what we want to do. So next, we can call it num, or this time around, let me call it n. We can call it nums or this way. So dot chomp. I mean, you can call it anything, of course. To string, to not to string, to integer, and then so I'm going to create two variables. One is going to be my, you know what, let's just, I think this is possible in Python too. Another, I think in React, yeah, in React, where you can do, in React we use const, you can have something like this. You can have when you're setting a state, you can do something like, if you're familiar with React, you can say first, comma set first, something like that. Then you can set equals to use state. You can maybe initialize it to 0 or whatever that you want it to be. So the same concept can be applied here, even in Python too, or some other language. So I can create two variables, a comma b here, and set it equals to my initial values, let's say 0 and 1. So these are two variables. This is the same thing as saying, a is equals to 0, and then b is equals to 1. Yeah, so you can do something like this. They are exactly, I think they're exactly the same thing. I think, yeah, they're exactly the same thing. So all I want to do here is to put my Fibonacci numbers. I'll be using the a loop. Okay, this time around, let's use we can use a while loop, or until. We can use until. You can use while loop. You can use for loop. You can use times loop, and you can use each loop. That is 5 types of loop. But let me use times loop this time around. So I'm going to say put, and so I'll say Fibonacci. see, Fibonacci series of numbers. Okay, let's say up to the number you typed. Okay, the number the user is going to type, which is n. We'll call it n. And then what I want to do is the number of times I want this n to run. So I'll just put that parenthesis there, that semicolon here. So I'll just say n dot times, so the number of times I want n to run. So I'll just say do. The way times work is just n times do. So I'm going to print that particular, put quote here, so I'm going to print that particular a. So I'll print a value, the number of times, and then I'm going to set new value. So by saying, I'm going to say a plus b, sorry, a comma b, which is going to be, I want to invert the number, so I'm going to say b comma, I'm going to say a plus b. Okay, very simple, very simple. And then what I want to do is simple. I'll just come over here and then end the program here. Okay, and then I will put just, at put empty space, and then I'll end my function program. I don't know if it makes sense, right? So these are Fibonacci. So you're going to see a series of numbers in my Fibonacci. Let me just run this program, right? Very quickly, let's run this program. All right. So hopefully there is no errors. Let me revisit this program. I think there should be the errors. Let's see. So it's going to say enter the number of times that I want to use for my Fibonacci this thing. So let me say 6, for example. So if I run it, it's going to give me that Fibonacci series for 6 times is going to be this particular time. So it's going to give me the numbers within the range of 6. So if you're going to plot a graph, for example, with this, you're going to be plotting it with this kind of numbers. So you can read off Fibonacci. It's a theory using data analysis for attributing data and doing some crazy and we call it sentiment. Is it sentiment analysis? No, it's not a sentiment analysis. I think it's fundamental analysis, under fundamental analysis, something like that. Okay. We'll have we can use plugins and all that, especially in trading. I know in forex trading you can use that. All right. So that is our program. So what if we want to okay, what if we want to do a menu for this program? This whole program we've written, I think we've written some couple of programs, right? So what if we want to write a menu whereby a user can select the program they want to run from here, right? So we can do that. So I'm going to write a menu that will enable us to select a program from here. So we can come over here and say menu driven. So just a menu dash driven program. So this is going to give us a control flow for this program. So instead of running the program one after the other, we can just bundle the program into one single program, whereby once we run it, we can select the particular one we want to run, and it's going to just run for us, right? I think that's very simple. So to do that, we're going to use a loop. So I'm going to say loop. Okay, do. And what I want to do is simple. I want to put our different programs. So the first program, let's make sure we put it in a new line. So I want it to be running in a different line. All the programs should be running in a different line, so I can select them differently. So this is going to output in a separate line. Let's call it a menu driven program. Let's call it menu let's call it this is control flow. So Ruby control flow. Okay, control flow menu. Let's put it in control flow menu program. Okay, Ruby control flow menu. It's fine, right? So it's okay. So here I can just put asterisk here, 5 asterisk here too. I can put 5 asterisk, okay. So you can have something like that. Very simple, very simple. So here I want to put the first program. So the first program we did was checking, let's see, odd and even number. So after odd and even number, we'll have positive 0 numbers and greatest number. So let's do this 3 first, so I don't forget it. Where are you? Okay, so the first one is, okay, let's put 1 here. So 1, we'll have to check odd or even. So say odd or even. So that's the first name of our first program. The second program is positive. Let's do number 2. So we're going to check positive or negative or 0. So, or let's say negative, positive comma negative, negative, or 0. All right. So put 3 is find the greatest number or the highest number. Let's use highest value, highest number value on highest value, highest number because highest number, highest number. All right, and the fourth, and let's look at that. So the fourth program here is we have the fourth program here. We have divine. Okay, we have positive number. We have greatest number of 3. We have a leap year. Okay, let's look at the leap year, grade system, and factorial. So leap year, grade system, and factorial. So we have put. So the fourth program will be leap year. Leap year check. The second one will be, the fifth one will be grade system. I think we call it, we'll call the results management system. So result management system. The fourth one is the sixth one. I keep saying, so the sixth one is factorial of a number. Factorial of a number. The seventh one is this is sum of first numbers. I think let's make sure that's what it is. Yeah, after grade system we have factorial. After factorial we have sum of nth number, multiplication table, reverse string, factorial, Fibonacci series. So let's say sum of numbers, sum of first numbers. Let's put another one. So we can say number 8. So 8 is going to be multiplication table, multiplication table. 9 is going to be reverse digits. Then the last one, puts 10, will be Fibonacci numbers. And finally we can exit the program. So we can have 11 for exiting of the program. So you're going to exit the program, and then finally we can just print something. You can now ask the user to enter a number to choose from this program. So you can say enter a number to choose, or enter a number to choose program. Yeah, so we can do something like that. So the number should be between 1 to 11. So let me do it that way. Then come over here and put dots. So that is what it is. So we're going to define a variable here. Still under our loop. So still inside this very loop, we're going to define a variable. I'll call it choice. Can I spell choice? So it equals to get the user's chomp. I say chomp users dot chomp dot. Make sure we're getting the integer. Okay. So we're going to use the switch statement. This is switch statement or case statement. So I'm going to use case of choice, depending on the choice they are going to choose. And what I want to do is say when the choice is 1, of course I'm going to run the odd or even program. When the case is When the case is 2, I'm going to run the positive 0 number. When the case is 3, I'm going to run the greatest number of 3. When the case is 4, I'm going to run the leap year check. When the case is 5, I'm going to run the result management system, grade system. When the case is 6, I'm going to be running the factorial of a number. When the case is when the case is 7, I'm going to be running sum of numbers. When the case is 8, I'm going to be running, let me see, okay, I'm going to be running multiple multiplication table. When the case is 9, I'm going to be running reverse string, reverse digits. And when the case is 10, I'll be running Fibonacci series. And then finally, when the case is 11, I want to exit the program, so I'll just say puts exiting program, lam. So I'll just do that, so it's just be, the program. And at the end of the day, I want to break out of this. So break is just a way of saying do not continue running this loop, stop the loop at this point. And then else, assuming any of these fails, I want to output that the person have entered an invalid number. So if you don't enter any number between 1 to 11, it means the number you entered is invalid. So I'm going to say invalid choice of number, or invalid choice. I'll just say please enter a valid number. Please enter a valid number, or I'll just say please enter a number between 1 to 11. Okay, that should be it. So we can now end our program. So just say end, and then also end our loop. That is it. So this is the end of the very program. So once you save and try to run this program again, let's take this up. So let's run this program again. So it's going to list out all this stuff for us and tell us to choose any program to run. So I'm going to choose let's choose 8. So I'm going to say 8. So it's going to ask me to enter a number from a multiplication table. So I've entered 5, press enter. I see that let's see, okay, it actually worked, but then the loop has to run again. Okay, it continues running. So this is multiplication table for 5. So it's going to say 5 times 1 is this. At the end of the day, it will run the program again and ask me to choose another program. If I choose let's choose a result management system. Let's choose 5. So result management system asks me to enter the score of the student. I'll enter 80, for example. So it will tell me that the student scored an A in the result management system. So and stuff like that. Once we are done, we can just press 11, and it is going to exit the program, and we are back here. So these are the control flows of a program that you can use to practice more with your yourself. So I'm going to push this code to GitHub, where you can also access the code if you want to, and we can forward from there. So if you have any question, post it in the comment section. Make sure you like, share, and subscribe to the channel to keep us going. Till next time, you take care of yourself and practice, because practice makes perfect.